In this video, we're going to solve our third example of finding a Thevenin equivalent circuit, and this is under what I consider the hardest of the three cases. This is case 3, where you only have dependent sources. Now, there is one part that's actually easy about this case, is that since there's no independent sources, then unless you plug a power supply between the two terminals A and B, there is nothing actually generating power to the circuit. There's nothing that's going to cause anything to actually happen. If you want to think about it as, well, okay, this is 4 times this voltage over here. Well, if that voltage is 0, then this is 0, and nothing's going to happen in the circuit. So what's going to be is that the VOC is 0 volts and the ISC is 0 amps. So right away you get the Thevenin voltage and the Norton current without doing any work. They're just 0. But the problem comes into finding your R Thevenin, because normally it would be VOC over ISC, but 0 over 0, we can't do that. It's an indeterminate form. Now, in a calculus class, if you have a limit like that, maybe you can do L'Hopital's rule or something, but that doesn't really work here. You're not going to be doing L'Hopital's rule on a circuit. So instead, what we're going to have to do is we're going to say, well, the resistance is based on, how much the current is going to go through with a given voltage. So what we're going to do is we're going to pretend there is an extra voltage source over here, and you can pick whatever value you want to. I'll call it 1 volt, and that's going to cause something to happen in our circuit, and then we're going to ask ourselves, what is the current that's going to go through here? And based on that, we're going to be able to figure out what our resistance is. So we put in what's called a test source, and you are free to put in a test source that's a voltage source or a current source. You are free to choose whatever numbers you want for the value of it, because you're just trying to find the ratio of voltage to current for resistance. So twice a voltage would have twice the current anyways. But now we have to solve this here. Now we can use node voltage or mesh current. I probably want to use mesh current just because we have multiple nodes here. So I'll go ahead and call that I1 and I2. So going around the first loop here, I would have 5I1 plus 10I1 plus 4Vx plus 15I1 minus I2 is equal to 0. Going around the second loop, I would have 15 I2 minus I1 plus the 1 volt equal to 0. Then since I have a dependent variable, I need to go ahead and figure out the relationship between the dependent variable and our mesh current variables. And based on this here, it looks like my Vx is going to be, since the I1 is coming out of the 5 ohm resistor, it's not following past the sign convention, it would be a negative 5I1. And I'll go ahead and substitute that up there, do some simplifications here. So let's see, I'm going to have a minus 5I1 there, so it's going to be a minus 20I1 plus 15 is minus 5 plus 15 is positive 10I1. And then at the end of that, it's going to be minus 15I2 is 0. And then on the second one, I will have minus 15I1 plus 15I2 is negative 1. We can go ahead and add down here. I have a minus 5I1 equals negative 1. I1 is going to be 1/5 amps. Plug that back up there to find what I2 is. So let's see here, 10 times 1/5 minus 15 I2 is 0. 15 I2 is going to be 2. So I2 is 2/15 amps. And then we know up here, based on our picture, that the red eye that we're looking for is really the opposite of I2. So it's going to be negative 2/15 amps. And now that we have our I, we can go ahead and say our Thevenin is the 1 volt voltage source divided by the current coming out of it is negative 2/15 amps, which we're going to get a negative 15 halves ohms. So our R Thevenin here, this is a weird case that can only happen in case 3, where you only have dependent sources, where we're going to, or sorry, could be case 2, but anytime you have dependent sources, you could end up having a negative R Thevenin. That is possible. It's, basically what's saying is your dependent sources are forcing things to go in the wrong direction from what you'd expect it to have happen. Now, keep in mind that you cannot physically have a resistor with a negative resistance. That is not possible. But what Thevenin equivalent circuits are, it's not saying you could physically build it. It's just saying there's a mathematical model that involves a resistor and a source, and at that point, it will still give you the same results, whether you use the mathematical model or the original circuit. And so in this case, our mathematical model is going to have a negative resistance. And as we said earlier, the Thevenin voltage is 0. So this strange circuit here would be our Thevenin equivalent circuit.